Evaluating limits by substitution. A lot of limits can be evaluated by direct substitution because, as you saw, if a function is continuous, what we can see is that as x approaches 3, well, that's just meaning that this will get closer to 3 squared, this will get closer to negative 5 times 3, and this will stay as 2. So, in this case, it would be the same thing as this. So 9 minus 15 plus 2, negative 6 plus 2 is negative 4. Here, the limit as x approaches negative pi over 3, 2 cosecant 2 times negative pi over 3, 2 times cosecant is 1 over sine of negative 2 pi over 3. Sine of negative 2 pi over 3 is negative square root of 3 over 2. So in this case, that's 2 times negative 2 over the square root of 3, which is negative 4 over the square root of 3. Or if we want to rationalize, negative 4 squared is 3 over 3. And because there's nothing fancy going on here in either of these, the limit is just when you substitute in. However, sometimes limits don't work, or you can't use limits with just direct substitution. For example, piecewise functions, or when a is a whole. For example, you have something like that. If we have a whole, then we can't plug in this value, so we need to evaluate the limit some other way. Or if we have limits at negative infinity or positive infinity, you obviously can't plug in infinity in for x. So these are cases where we will have to evaluate limits with another method besides substitution. These two are essentially saying that the function is not continuous. Continuous. So as long as the function is continuous and the value that we're talking about approaching is a finite value, then we can typically evaluate with direct substitution. Thanks.